Hello everybody, it's May the 1st, well actually local time it's actually May the 2nd, 1:07 a.m. in the morning. Just took a flight back from Dallas, pretty tired, but we still have, LeetCode is based on, I think it's based on Pacific time, right? Yeah, it's based on Pacific time, so it's 10:07 p.m. So basically, we still have 2 hours left to solve today's problem. All right, so let's get to it. Said that we try our best not to miss even a single day. So this is how we're gonna try. All right, let's do this. I hope it's not a hard problem because I really don't have any capacity to do hard problems. Okay, I think I'm on the wrong one. This is still showing April, so I think I need to go to explore and go for May. Where is May? Are they not doing May? April, May is here. They are doing May. Of course they're doing May. Why would they not doing May? Yeah. All right. Let's take a look. Prefix and suffix search. Design a special dictionary which has some words and allows you to search the words in it by a prefix and a suffix. Implement the word filter class. Word filter string words initializes the object with the words in the dictionary. We call F. String prefix, string suffix returns the index of the word in the dictionary, which has the prefix and the suffix. If there's more than one valid index, return the largest of them. If there is no such word in the dictionary, return -1. Okay, input. Word filter F. Apple. AE. Word filter equals new word filter apple. That's the word put in the dictionary. We call .f, call AE, return 0 because the word at 0 has prefix and suffix e. Okay. The length is this. Each word is 10 in length. Prefix and suffix is about 10. Lowercase English letters only. At most 15,000 calls we made to F. Okay. All right. So I'll give you a list of words. I'm going to turn on my fan. It's hot. So we're given a list of words, right? We have words. In a dictionary, we want to know prefix and suffix. Are we talking about building 2 tries? Build 1 try from the suffix and build another try from the back, from front and from back. So I search from the front. You search from the front. You end up with, a list of words. It could be a set, right? A set of words. And then you make a suffix and also a try. And each value you can store a suffix. On suffix, each value you just store a set that's currently here. Okay, and then you search both. You get 2 set. You take the intersection of the set and you return the largest of the set. Okay, let's just try this. If it doesn't work, we're going to check the result because I am not going to spend too much time in this. Oh, we have to build a new one. The make directory. 2021 May challenge. And then we're going to copy. Now instead of, we're going to go, wow, time flies. It's already May. Man, what have we done? I mean, we've done a lot. I don't even remember when I started streaming. Huh. Doesn't matter. What I know is we're gonna go back to Vim. Oh, we actually also go back to 2 screens, so it's easier for me to handle the workload. All right, so no keyboard, no keyboard, no mouse. All right, let's say we're gonna do 0, right, and then go V, and we're gonna go just use this D. Okay, and we're gonna also copy and paste. I have to copy and paste using mouse here. Paste. Okay. Now, initialize. We need to build 2 tries. I think we can use default dict to do try. I kind of not 100% sure, so I'm gonna go here. Say from what? From collections. Import default dict. Okay, and then we're gonna go to 9. I'm gonna say default dict self dot pre equals default dict lambda self dot pre. I think that's how you define it, right? Pre default dict. Anything will get another default dict. Yeah, I think that's how it works. And then we're gonna go to the end. Oh, no, have this. And then we're gonna V0. V0 is too much W, and we're gonna yank, right? And then we're gonna go here to, oh no, I think the yank is right. Let's try it again. V0W. Why is not working yank? Why is copy, right? Oh, I know. O has to be P. There we go. That's the one. So we're gonna go L. So this is not gonna be pre. This is gonna be suffix, right? And then we're gonna jump to the end, which is $. No, which is $. Jump to the end, A, and then that's gonna be suffix. Okay, so I have this. We also need def make pre try, and then self. That's it. And we are also gonna go up here. This and O self dot words equals words. Okay, so go down. Cat finally found the toy. I think he's going to enjoy, which is good. Okay, so how do we do this? We are going to say for I word. Oh, nah, let's just do it 2 times. Words length 15,000. Should be fine. So we have to go each word, and we have to run from front to back, from back to front. I mean, from front to back, and back to front. We can do it at the same time, right? Self.words. I don't know. Try it. So it's word, and I'm gonna say for. What is the try gonna look like? The node, right? So gonna be a word. No, that's a node. And initial node, we'll get a word. and then it goes another node, but we also need to have a value. We need to have a value here. So it cannot just be default dict. I need to have a value. The value needs to store the current. Okay, this is not gonna work. So we need another one. Try node. We have to do try node. Alright, so we're gonna go to 5. So say class try node. Alright, and then def initiate self. We need to pass the letter. Try node has a default dict. Children, right? Children. And we have a letter and index, right? Here, what do we have? We can use this. No, that's because you're moving your hand. So I'm gonna say self dot children equals default dict. No, we actually don't need default dict. And just the dict, right? It's just the dict. And then self dot indices equals a set. You know what? Why do you do that? No, let's don't pass anything. Just you know, just simple, right? Let's not pass anything because if we pass anything, then we have to run it ourselves. I want to handle the logic as we're doing it. Yeah, I want to handle the logic as we are doing it. Okay, so we need this, and that's about it. All right. Okay, so that's the try node, and then pre is going to be a try node. So we're going to go to 14, and then we're going to say equals nope here, and then we say try node, right? Okay, that's fine. And then we're going to go do the same thing down. Back. Say v to the end, delete, insert try node. Okay. Now let's do 20. So here, a word in this. We actually need to go on node. So G18, no. And then say node equals self.pre, right? And then, ow, ah! My cat is biting my foot. Go here, and then say for letter in word, all right? So for letter in word, I will say node dot children. Node dot children is a dict. It's a letter is going to be what? It's going to be a new try node. Set up to a new try node. And what? And node dot indices dot add I, right? And then we also gonna move the node. So we say node equals node.children letter. So move the node, the next node, so we're gonna go all the way down. Once we're done, I'll go back to come up to the next word. And the next word will get out. Okay, I think 19G is not, oh shoot. 19G, we need to copy this. So we go W and V $, we need to yank this and then delete this and then go to here and paste this. Oh shoot! I do it again. Here we're gonna delete this. And then let's use this. We're gonna go to next one. Then paste this. There we go. So every time a new word coming in, we reset the node, and then we go through. That's make the pre-try, right? So we also going to make the post-try, which means we're gonna go to 18 V, and then we're gonna say yank, and then go to 25, and then we're gonna paste it. Actually, so I think this one is one too much, so we're gonna also go to 32. Oh no, just 32. No, up. Okay, and then we're gonna go to 20. So we're gonna go to 26, and I'm gonna go to P. I'm gonna change 3. Oh, change time 3. I don't think that's the word. I think it's 3C. No. How do you use change? E? No, that's not what we want. I cannot change it x3. Alright, I'll just go 3. No, that's sub. And each word and 28. So we're gonna go 28G, find dot, actually find I'm gonna say D towards the end of the word, and then we're gonna say dot, oh shoot, over here dot sub, right? And then we need to do word reverse. So we're gonna go down. This is gonna be right, word reverse. Yeah, my room, my house, my apartment smells weird. Okay. Alright, so we have this, which means we also need to go back to no, we go back to 17, like 16, and then we have self.make pre, right? And then we're gonna say self.make sub, okay? And then we're gonna go to 37, and then we'll try preset equals equals. Oh, we have to go through the try. So when I say, what do we say? We say giving prefix, right? So node equals node pre equals self.pre, right? And then for letter in prefix, for letter in prefix, if letter in node pre dot children, right? Then we say node pre equals node pre dot children let else if let's not, then we're gonna break, right? So that's that, and we're gonna do, hold on, so the suffix, do we come in order? That's a question. All right, let's try this. I'm not sure, because you see the apple is this, right? What if I do PE? No, is it LE? Let's just see, how does this one respond? Aye. Turn 0. So do we go this way? Indentation, self.full, equal to 0. That should work. No 0. So LE says it's correct. So LE is correct. How about EL? So E and L. So EL probably is not correct. Yep, EL is not correct, which means the suffix is also read from left to right. Okay, so suffix also read from left to right. That means suffix left to right. That means, first of all, we need to go copy everything. So we're gonna say W, and then V, and then let's see. Oh, I can do this. Yank, and 42 G O, and then paste. We have to do this, and then this is going to be how do we delete things from the behind? I mean, we can just change to end. That's suff, right? And then we're gonna go to the end, and it's gonna be suff, and go down one. This is going to be a suffix, and we have to go reverse style suffix. Children, okay. So after these two, we actually can also delete. No, we also can delete this line. It's not necessary. So we go to 49. 49. Let's say intersect. Res equals node pre dot intersection node suff dot indices. I forgot to say indices. This indices, and we also have to go back, back pre dot, so dot indices dot this, that's a res, and then we can go let's say if return max res if res else minus 1. Okay, so we're gonna go V, and then we're gonna go what, and all the way to I think 6 GG. GG. No. 50 GG, and then we're gonna go to the end. Right, V6G, and then we can actually go a little bit higher. Actually, I cannot see. Oh, it's like a 5G. Okay, now we're gonna copy this because we have to move here. Okay, let's try it. Oh, minus 1. Too many values to unpack. Oh, I forgot a self dot. Yeah. Oh man. So let's make changes here. So we're gonna go to 21 and find dot. Go to B and then enumerate. Oh, holy moly! 21 and dot going forward. Insert enumerate. Then we're gonna go to the E and A this. Okay. So I want to copy this whole line. Therefore, we go here. Yank. And then I'm going to go to 29. And DD. O. And paste. And that's not the ones. The heck? Oh, because I used the DD. I shoot. So I want to use change, right? Change. Paste. No, that's not gonna work. So we're gonna go back to 21. Right? We're gonna go P. I want to choose all the way to the end. I'm gonna yank, and then we're gonna go to 29 and change to the end. And paste it. Why is it not working? Why the yank's not working, huh? Hold on, let me see. Let me see the cheat sheet. Copy a line. Yank W, copy character, yank to the end. Okay, let's try it again. Go to 21. Yank to the end. And then we're gonna go to 29. Let's just we're gonna go to the front and a P. There we go. That's what we're talking about. However, we have an issue, which means we need to fix, and then we're gonna go down the line and delete this line. Okay, so again, we're gonna go 5G, and then we're gonna copy the whole thing. So C, come in here, so V, try again. Oh, no, what the hell happened? If res else minus 1. I don't know. If res else minus 1. Okay. Alright, let's try this again. Am I running? No, not running. Your answer is 0. How is my answer 0? I said I'm doing a suffix. Minus 1. L coming in, it should be a... Huh? This is not looking good. Yeah, I said would gonna be in reverse, and suffix gonna be in reverse. Oh, suffix. Hold on. Do we do suffix in reverse? Yeah, suffix need to be in reverse, which means suffix, if this one in reverse, L comes in first. If L comes in first, oh, I already have. Shouldn't that be? Hold on. The original free should be an empty node, right? It should be an empty node. And then, oh, so it's this one is wrong. So for this, and yes, so for this, and node equals, and now we say for lettering node, we put a letter in it, right? And then go to the next one. I think these two lines need to change. We'll go to the next one and then add the index, because current, like the original node, the root node is an empty node, and then we have the H, we have the letter, and we'll go to the node, and that node contains that. So we say index plus 1, and then for the next one, okay, so we're gonna do the same thing here as well, right? We're gonna do here as well. We get the node first, and then we do it. Okay, this one, run it. Okay, that one's correct. Now when we do EL, that one should give us 0. EL, huh? Why EL is wrong too? Wait. E. Hold on. Why EL is wrong? No, EL is wrong. LE shall be right. Right? LE shall be correct. But my answer is also -1. Okay. There is issue. There is serious issue. Okay. So here is this. If it's in, my node go to the children node, and coming up, if it's in, go to children's node, and if it's not, that's it. Suffix, same thing. We go to reverse it, right? Reverse it. So E coming in, E should be good. Coming back, oh, this is wrong. Not supposed to be pre. This should be suff. And this is also suff. They should all be suff. This should be suff as well. Suff. No suff, dot suff. This is also suff. And then no suff, then this is res. This is a pre dot index intersection suff. All right, try it again. Okay, this one's correct. Give it a shot. Pending, judging. Ay. This is not right. How? How is this not correct? I mean, we follow. All right, so first one we got it. 1, 2. The second one shall be 4, but I get by minus 1. Okay, so we got this 8 is correct. I got a couple wrong. How? Did we do it wrong? Alright, let's try this test case. We're not gonna do those so much. We're just gonna do 2, so we kind of be able to see what goes wrong. So we can have all of them, but we only do calling 2. So the first one and the second one, and all these we're not going to call. Okay, so all these we're not going to call. So run it. Yep. All right, so the first one is correct. We don't even have to call. Let's just call 1. So the first one is correct. Let's do not call it, and just call 1. All right. I just fell from my chair. Nothing biggie, I just fell from my chair. Okay, so the suffix is A, B, C, A, C, C, B, C, A, A. So it should be 4. 0, 1, 2, 3, 4. Ah, yes, that is true. Well, I should delete everything else. It's just clutter. AB is here. So what I want to do is we're gonna print out what? Print out. Yeah, just print node pre. So node pre dot children, right? And node pre dot indices. I'll do the same thing for here. This is going to be node suff and node suff. So kind of just give an idea of what we are dealing with. Now pre give us a C. Got a C. Okay, yeah. And we have a node which will put 4 in. Okay. And reverse. We're going back to the top. So when we do reverse, we have this. So, okay, hold on. So we do reverse, right? We do reverse. That's a 4. That is a 4. How the result? How the result? How the result not be 4? Do they both print out 4? Expected answer. Oh, this one's correct. Wait, what? How is this correct? It was not correct earlier. Hold a sec. I mean, it was not correct earlier. I didn't change anything. I just put a print and it suddenly becomes correct. Comment them out. Try this one again. Yep, that's now correct. So there's a side effect. Right? Like if we remove this and oh shoot, too many F's. If we remove this, then it was correct. What? Wait! What the hell? Now both are not correct. What did you do? It was correct, right? We did see it was correct earlier. All right, this is now correct. 7. What? Zero, 1, 2, 3, 4. Oh, did you delete all these things as well? 5. Oh, I delete all these as well. Oh, now we have an issue. AB, right? We have AB coming in. A. We have all the. We have 0, 1, 2, 3, 4, 5, 6, 7. What happened to this AB? What happened to 4? I say indices.add. And every time the next word, we go back to the start. And then we say, if we say for each letter in the node, we can check. Oh, I see. I see here. If letter not in node.children, then we do this. Ah, yes. Now I see the problem. I forgot to add this one. Now they shall be correct. There we go. Now we're right. Okay, so comment out the print statement and go back to this. There we go. Oh, correct. Okay. Let's remove this. Submit again. Please don't time out. Please don't time out. Please don't time out. Judging. Come on. We're looking at timeout. Or shoot. Shoot. Okay. I mean, what's the... Oh, we're gonna... So we still have time, but... So, timeout. How do we time out? I think it's just the same thing over and over again. I mean, let's see. I want to check on the I want to check on this. Oh, it's a hard one. Okay, let's check what went wrong. What the? So just bunch of F, and then holy moly, it's just the same thing over and over and over again. Okay. So A is the same word, and then we need to check the suffix. Which part takes the longest time? Alright, don't want to waste time. Let's just take a look at a hint. For a word like test, consider this, this and this. Then if we have a query like prefix te and suffix t, we can find it by searching for something we've inserted, starting from t star te. Oh, look at that! Look at that! We append the suffix at the beginning. We append it at the beginning. We append it at the beginning. But I think there's another way we can do this. It's like every time we get a word in, actually we're gonna do set words, right? So we make sure that it don't repeat. And as we are calling prefix and suffix, we can also have another trick when you say self dot memo, right? It's gonna be a memo, and then we say prefix suffix and say if, or well, hold on, yeah, it's a if key equals prefix plus this plus suffix, and if key in and not in self.memo, right? And then we do all this, blah blah and blah, and we say self.memo key equals, copy and paste this, and then we'll also return self.memo key, right? So two methods. Hopefully we can speed things up. Let's try see if this one speed things up. Pending, judging. I got wrong answer. I got wrong answer. Okay. Why did I get a wrong answer? I added this, so prefix and suffix is separated. And I add a set, which should be fine because, okay, that's actually not fine. That's actually not fine. Okay, we have to do list because the index is wrong. Oh, the index. Okay, index can. Okay. But we can do it. We just need to discard. Like if the word is already in it, we just need to discard it. Right? Hold on. We want the largest. We want the largest of them. So we have to pick from back to front. Right? From back to front. We have to go from back to front. And then we put in the largest one. If it appears again, then we ignore it. Right? If it appears again, then we ignore it. Okay, so it's going to be like this. Scene equals a set, right? So, that's not going to be this way. Say for I in range, len self.words minus 1, right? And then I'm going to say word equals self.words I, right? And then we say if word in scene, right? And then we're going to continue. Else scene.add word, and then we do our shenanigans, and then we'll come out. So we do exactly the same thing here. Exactly the same thing. Well, I'll say scene. I have to put scene here. Scene equals set, right? So we get a word. If we have seen a word and we don't do it, so with this, let's check. It should be correct. Yeah. All right. Try it again. Judging. Accepted. All right. So that's not what it's supposed to be, but we did pass it with fairly good result. I did not expect that to happen. Okay, so wow, a lot of I mean, did we take the hint? Yes, we actually did, because the key idea is from here. But I do think even in the actual thing, we do have to do it this way, because we have to avoid doing over and over again. It's like the indices, right? Because we have repeated words. If we have repeated words, we only want to save the word that has the largest index. All right, let's come back to here. We're gonna go. Let's say V. I'll just do this and D, and we'll say insert. Not Control V. Okay. Now we are going to write some comments. G, probably 5G. Yep. No, it's going to be, let's write in 12G. Okay. So go here, and we say we did check out the hint, but did not use the hint. We did, however, check the failed test case to realize that it is crucial to pre-process the data to avoid repetition. The way to avoid repetition in the input words is to only count the word that appears the first time from back to front. The reason we check back to front is that we are required to always return the bigger index if more than one indices are available. The second part of avoiding repetition is to set up a memo such that if repeats in prefix and suffix happens, we can immediately return the result. With these two trickery implemented, this problem can be resolved with a simple setup, with a simple solution. Create two tries, one for prefix and one for suffix. And then we search the given prefix to return a set of indices that satisfy the prefix. We do the same thing for the suffix. and then take the intersection of the two result in sets. If the set is empty, empty, we return -1. Otherwise, return the max in the set. Okay, so that's that. This one will run O n m, where n is the total number of words and m is the length of each word. We run a pretty good result. If you take a look here, we run at 672 milliseconds, and that gave us a 90% ranking. But of course, we are going to try the hint method as well. The hint method is very smart. Basically, it's saying we can build one for each word coming in. We can build a try for all type of situations. So we build a try for this, right? For this, and this. We build try for each one of them. And then when we have a prefix and suffix, we put the suffix first, add this, and then we search. Yep, so we only need to build one try. Let's do this. We still have some time, so how are we going to approach it? Same thing. So we have a try node, and let's see. It's not working. So we're gonna do. It's actually slower. Yeah, I think use the best of the tool. Don't be, don't be, you don't have to, right? Use the best of all the tools, and right. So you're faster in doing this. So we're gonna say no. We still should try our best not to rely too much on the other thing. Oh, what did you do? What did you do? So I say this, and I go J, and I delete all of them. Yep. And in current case, we don't need all this. We just need a try. Let's just call it try. So we're gonna say C to the end of word dot try, right? And then coming here, nope. Go down. We don't need this. We do need this. And here we can say just say make try. And go down here, delete this. Memo as well. We need both of them. And go down here. Same thing. We're gonna delete this. Yes. Okay. So here is the difference. So we have to. What do? We say that we'll make a try. Right? So make a try, we add all these things into the try. And we search, I'm gonna search once. Okay, so it's not gonna be for a letter in this, it's going to be for so T and then ST. What is this? To the end, right? So from the start to the end. From start to the end. Oh, we see the test doesn't change. The test does not change. So we don't have to build a prefix try. It's basically we build this and this and this and this and this. Hold on, how do we build a try? Oh, we don't build a try. Hold on, there's no try, right? We just put all these in a dictionary. Yeah, we put all these as the keys in dictionary with a value. And yeah, there's no try. No, there is a try because we'll build a try for each one of these so we can search. Yeah, we'll build a try for each one of these. Yes, we'll build a try for each one of these. Okay. Okay, so we have the word, and we need to build a try for each one of these. So it's going to be the front, right, to the end, test, and then next one to the end. So we're going to say for letter. No, we're going to do, let me see, it's going to be for J in range len word. So it's gonna go to 0, 1, 2, 3. So 3 to the end. It's going to be by itself. So it's actually going to, we're gonna do one more at the end, right? I'll be like, I think we'll consider it out of range. So 0 to the end, that's a test. 1, 2, 3 to the end. 4 to the end. Hold on, what's 4 to the end? That's a good question. Let's try. Say A equals test, right? A, 3 to the end is T. What about 4 to the end? Oh, okay, that's possible. So we're just gonna go +1, right? And then we're gonna say try word equals word J to the end plus this plus word, right? And then we're gonna go down, and I think everything needs to let's say J, everything needs to go over here, and this is not going to be word, this is going to be try word, right? So for that in try word, we build the try, and then we're going to go to 122. I think this does not need, we don't need this one anymore. And then when we do this, we have key, right? And then the same thing. We're gonna say if the key is not in self.memo, then we try this, and we just say node. So we're gonna say node equals node equals. Well, what did you do? Not the most sufficient, not most proficient, not very good at this, mind you. This is gonna be try, right? And then for letter in key, yeah, it's gonna be key. So we go down and we go to the end. We're gonna say change to the beginning. We're gonna say this one is key, and we don't need this one, right? For letter in key, letter in. So now we can search node pre, right? How do we change? Oh, we are going to do something like this. So we're gonna go J's here. So I'm gonna select the next word to the end, and then we'll do the insert. Oh, visual mode will have to get out. Hold on. Hold on. Let's do visual mode. I don't know how to handle this. No. I think I succeeded once, but I don't know how to do it again. All right, try it again. So let's say we do this. That's visual mode, right? And we say D. Oh, we have to D and then insert. Delete and then insert. What's gonna be node? Oh, delete and insert. Okay. So node, and then I always type this one first. So go up. We need this. So for node, blah blah blah, and we can directly say, okay, let's try. Let's try this. We're gonna go to line 99 and visual mode. See here. We don't want this anymore. We're gonna go to solutions, but we're gonna try the second method that we have. We don't need this too much. Oh, we do need this. All right, give it a shot. See how this one goes. Node.try. Okay, try it again. Res is not defined. Well, it is not res, it's no.children. That's true, it's no.children. If no.children, else that is not correct. Indices. I don't know why you say .children. Doesn't make any sense to me. Yeah. Just try it. I got a wrong answer. Huh. Why? I failed on the same one. Exact same thing that we failed last time. Try for J in range. Yeah, so 0 to the end, 1 to the end, 2 to the end, plus word, and then we go to try. Hold on, I think this is the problem. A node has to be here. Try word equals word. But before, how about this? We move this before we start the try. Slightly different. Also wrong. Okay. Okay, okie dokie. Oh, no hard feelings. Think about it again. Node is try, right? And we have a word. Now for the letter in the try word, we're trying to put it inside. Node of children equals try node equals letter and the indices plus is here. And then we say the letter in the key. Oh, it's suffix plus. Yeah, that is wrong. It's suffix plus this plus prefix. Suffix and prefix is swapped. There we go. This one shall be right. Yep. This one is correct. Nice. Nice. Okay, coming here. Nope. Let's say this one could be 1. Can we go back up slowly? Yep, so we're gonna say 89 at the bottom, just 2. No. Put the front, V, and delete, copy and paste, and go back to the 89. So we're gonna go 89, put the tail, 2. And we're gonna do here. So what we're gonna say is this is the method recommended. This is the method I implemented based on the hint. We create new new keys to build the try. For example, if the input text, if input is test, the keys for try are this test, and actually we're gonna do like this test, right? And then est test, and then st test, and then t test, and finally this test. We build try for each key, and during search we produce a new key called suffix plus this plus prefix, and then use the new key to search the try. We also include the trickery of not repeating on the input words or the prefix suffix pair. Okay. Oh, what is this? Too many, so I'm gonna go here, so we want this. What else? Blank line, 97, so we want a blank line. What else? Y spaces, Y spaces. So go to here, oh. Go to the end, deleted. So 5, go to the end, delete, what else? 7, 117, delete, and 127, nope, 127, go to the end. Oh, that's a lot. And more. We're gonna go to 134. Alright, not everybody's happy. Oh, shoot. Not everybody's happy. Okay, so I'll go to what? This? Use the best tool. We did not use default text, that's true. Okay, alright, so let's take a look at the solution. First of all, I mean, we basically solved it ourselves, right? Because if you think about it, we did use our method of 2 tries to solve it. It's just it timed out, but we did find out the reason why it timed out. So it's all fine. Try plus set intersection. Course set could be large. Careful. Yeah, it needs to be careful. Paired try. I mean, you can. This one can work. Gotta wait. AEPL, LPEA. Find a node. Hold on. AEPL, PP, LPEA. AE, P none, P none. There's the wrapped words. Yeah, wrapped words is very smart. I agree. Yeah, but it can be solved by using a little bit of trickery, right? By a little bit of trickery while we're doing it. I mean, it's also possible, like, we combine these two together because we're doing the same thing here, right? We just need the two nodes, and we go it once and we go it twice. So it's also possible to combine the two. 3 ways. Method 1. This is a wraparound, I think. This is a wraparound. 2. There's a 2, right? What is this method 3? Uh, a word, substring. Okay. Get, suffix, get. Ah, what is this? Integers, a list of integers. Map prefix. Dot get prefix. Dot contains keys. Now contain, return this. If contain, how can you do the prefix directly? It's a hash map. Right? So it's actually each individual. Oh, it's not. Oh, it's not. It's. Oh, wow. This is. The space complexity is huge. Oh, it's put all the prefix as keys, all the prefix, and all the suffix as keys. And then we just get them. Alright? All the prefix as keys, all the suffix as keys. And we have this. And we say p.getI smaller than s.getj, j minus minus. Huh? Hold on, what are you storing? Let's store the. It stores a list of things that has the prefix. Yeah, there's prefix as the key. It stores a list of the indices that has the same prefix. All right, so we get the list. We just need to know if they are exactly the same. So we're going back to front. Yes, back to front. If I, that's the index, right? If I is smaller than this, that means J has to go front. J, yeah, because that doesn't match. We want to find the one that match. Find the first one that match. So J go to front, and I go to front until we get it. Oh, okay. How about this one? Input length. Start with input. Start with an input. Oh, ha. This one, is this one gonna pass? I don't think so. I don't think so. It's an L. I don't think so. You have to search every single time. No, I don't think this one is good. All right, that's it. I don't want to keep reading. I mean, the try is, I mean, the other method is, it's not a try, right? It's not a try. It's basically just find all the prefix. And actually, if you find all the prefix, that's O, that is O N M. That's the same, right? This is O N M. That's also O N M. And when you find, but just the space complexity is it's huge, right? It's huge. The try reduces space complexity. Now it has to be try, and the wraparound is a very smart way to go. But our other method's good as well. All right, that's it. I don't want to keep too much time on this. Good. We actually finished it before the deadline, so it's actually what 11:35 Pacific time, so it's good. All right, we will end it now and see you guys, later, a few hours later. Adios.